Welcome to Learning Goal 2. We are going to be now using what we learned before to solve story problems that involve volume. So make sure that on your nice new sheet of paper you have that written down at the top. And we're going to start, like always, with a little bit of vocab. And there's actually going to be 3 words you're going to have to write down, so make sure that if we go too fast, you pause it. But the first one is length. Now, this should not be anything new. I know you've talked about length in first grade, second grade, every grade probably up until now. But length describes how wide, tall, or long an object is. It is one-dimensional. One. So, for example, this little ball of yarn. It would require, if you wanted to measure how long it was, it would require one measurement. So length is one-dimensional, so make sure you write that down. The second one we've talked about this year is area. And again, this is a little bit of review, but still, please write it down. Area tells how much surface a figure covers, and that is two-dimensional. And we're actually going to be using a little bit of area today in what we do in this lesson. So again, it tells how much surface area a figure covers, and it's two-dimensional. You would measure that in square units if you remember. So this piece of paper, for example, you would find the area would require you to find the length and the width, the 2 dimensions. And then the last one, you can probably guess, we've done length, area, and our new one is volume. Volume tells how much space an object occupies, and it is 3-dimensional. It is measured in cubic units, which we talked about in Learning Goal 1. So if you were measuring the volume of this Rubik's Cube, you would have to measure the length, the width, and the height, so 3 dimensions. So make sure that you have those 3 vocab words written down. You're laughing at.
It looked like you were doing some signs or something. I don't know.
That's all. Yeah, didn't think of that. All right, and now it is your turn to talk about being able to compare them.
Yeah, so just in your notebook, I know you took a little bit of notes, but we just want you to jot down the answer. You don't have to jot down all the scenarios here, but just like think about this first situation here. How tall are you? Would you use length, area, or volume to figure out how tall you were? So just pause for a sec, think about it, and in your notebook, you should have written something down like length. Yep. How tall you are is how long you are. 1 dimension.
Yep.
Next one, how much space is inside a refrigerator? What do you think you would use for that? Length, area, or volume? So once again, take a little guess at that. And you should have thought about volume in this case. And because how much space does it take to fill up the
whole
refrigerator?
fridge, which is a 3-dimensional shape.
Yeah. And last one, we have how much wallpaper is needed for one wall. If you just wanted to cover up one wall, what would you want to use to figure that out? And you should be thinking area. The length and the width of or probably length and height of the wall would fill in the area. We have this rectangular prism. It is 4 decimeters long and then 2 decimeters wide, and it is 3 decimeters tall, or that's how high it is. So what is the volume of the box? So thinking back to Learning Goal 1, you are going to want to think about that we want to figure out length times width times height. So that is 2 times 3 times 4. And then you should get an answer of 24 decimeters cubed, or cubic decimeters. Yep. Now that you've seen that example, we want you to just take a moment to try this one. We will share the answer in a moment, but think about how if you have a flower box and it's 3 feet long and 2 feet wide and 1 foot deep, then how many cubic feet of soil can it hold? So pause, try please. So you should have 3 times 2 times 1 as our formula that you're plugging in your numbers with, and that would equal 6 cubic feet.
Yep. And this is really like the simplest type of a volume story problem. Sometimes you're going to run into problems like this one where you're missing one of the dimensions rather than missing the volume, the total. So we're going to do a practice one here, and then you'll try one and we'll give you the answer just like before. So in this case, we're talking about fudge. Yum. There are 96 cubes of fudge on a tray. So that's the total volume right there, 96 total cubes. The top layer of the tray has 48 cubes. So if you're thinking about like the 2 layers like we saw in the video before, one of the layers is complete with 48. So how many layers are there total? So I'm trying to think of what I'm missing. So if one layer is the length times the width, I'm missing my height. So in this case, 48 is my length times width. So, you know, the dimensions could have been a whole bunch of things, but together, those two multiplied to get to 48 times the height will get us to 96. So knowing that equation, length times width times height, is going to be really important for these where you're missing some. So in this case, 48 times what is going to get me to 96? And, you know, yeah, I don't know that for sure, but I can guess. 48 is close to 50. 50 is times 2 I know is 100, which is really close to 96. And you know we're not going to give you a problem. That's not going to work out perfect. So I would try out 2 first, and that is actually the correct answer. So 48 times 2 gave us 96, so there are actually 2 layers of fudge. And the next one, you are going to try, and we will give you the answer, but please make an effort to try it first. Think back to what we just talked about finding the correct dimensions. So in this case, a present has just arrived for you. The top of the box is 34 square centimeters in area. So we found the top of the box is already 34 square centimeters. So we know that area already. The volume of the total box is 340 cubic centimeters. So what is the height? So go ahead and pause it and try and see if you can figure it out. And then we'll give you the answer in just a second. Okay, so again, I know 34 is my area of the top. So my length times width together gave me 34. And I multiply that by my height, should give me 340. So 34 times what gives me 340? The answer is 10. So my height is 10 centimeters. So hopefully you got that in your journal. You got it right.
And this is another one where you really have to think about them a little bit more here. So we have a sandbox, and I'm sure a lot of you remember enjoying sandboxes back in your younger days. So a sandbox has a width of 5 feet, and then a length of 4 feet, and a height of 1 foot. So the first question though here is, how much ground does it cover? And that sort of goes back to those scenarios of, you know, when do we want to use length and area and volume? And when I think about how much space does something cover, I'm thinking that's more two-dimensional then. That's covering up area. So here we want to think about how much ground does it cover. If I want to figure out how much space it's going to take up in my yard, I want to think about the width and the length here. So I'm going to think about how we have 5 times 4 feet, and that would give me 20 square feet. That's how much ground cover this is going to take up.
So what you're actually finding is something called the surface area. So you'll hear that sometime in math, but basically you're figuring out how much space that surface takes up.
Now, this is, once we figure this out, then it's a little bit easier. What is the volume of the sandbox? And that's where we can go back to plugging in our length times width times height. So we will have 5 times 4 again, and then just adding the height here, times 1.
And we could have done, like in the last examples where it already had the area for you, we could have just filled in the 20 for the 5 times 4. It would have been the same type of thing as we did in the last example, just to sort of make that connection.
Yeah. And what's interesting is you still get the same answer, 20, but now what we're answering is how much space would it take to fill this up? Maybe figuring out how much sand would we need to buy to fill up this space. So now that you have a handy-dandy example, you are going to get to try to solve this, and take a moment to, let's read through it, and we'll sort of walk you through it, but then pause and try to solve this, and we'll share the answer. But Mr. Van Dam, yay, he bought a new TV for us. That's exciting. The box had a length of 6 feet, ooh, a nice big one, and a width of 2 feet, and a height of 4 feet. How much wall space is this TV going to take up? So you're going to want to think about that wall space and think about dimensions that you need for that. And then what was the volume of the box?
That might help you to draw a picture if that helps you and label the different dimensions. But so you're actually answering 2 questions there.
Yes. All right. So for the first question, how much wall space did the TV take up? I want to think about then how long is it, and then how tall is it, because that's what's going to cover up my wall now. So 6 times 4 equals 24 square feet. That's what we would want to figure in for our wall space. That's the area. Now, what is the volume of the box? We just need to think about 6 times 4 again. That's our surface area, times 2, adding in the width as well. And so that would take up 48 cubic feet.
All right, now you get a chance to try 3 on your own, and I'm going to read through them with you, but just before I do that, each of these examples that you're going to do ties back to the practice problems that we just did. So if you get stuck on the first one, go back and look at the first examples we did. If you get stuck on the second one, look at the second examples we did. So first one, we've got our truck. The cargo area of the truck measures 4 meters long, 2 meters wide, and 1 meter deep. How many cubic meters of cargo will fit in that space? Number 2, and if you could number them, I know we don't have them numbered, but you should number them. I just thought of that. It'll make it a lot easier when we go through them. A cereal box has a height of 15 inches and is 3 inches deep. The volume of the box is 450 inches cubed. What is the length? So again, look back. I would maybe fill in an equation. I don't know. Just give it a shot. And the third one, a fridge has a length of 3 feet, a width of 2 feet, and a height of 6 feet. How much floor space does the bottom take up? So that's part 1. And what is the volume of the fridge? So go ahead and try those 3 questions. Come back with them answered. I don't know is not an acceptable answer. Try them first, and then if you're stuck, we will go over them if you get them wrong. So, and that is it. So we shall see you tomorrow.